All right, let's write a couple of direct variation equations. And so they're going to be equations that look something like this, where um, some variable equals some other variable times some constant. That's basically what that's saying. So so for example, just something boring, y equals 3x, which means y is always 3 times as big as x. That 3 would be the constant, and it defines, what multiple of x is y. So if this y is a constant multiple of x, meaning it's always, some, 3 times as big as x, 4 times as big as x, 1/2 the size of x, if it's always, that same multiple of x, that would be called a direct variation. Um, yeah, and you can also just, a little side note here, if your direct variation works like this, y equals 3x, oops, I'm getting ahead of myself, 3x, um, 3x, where that's the constant of variation. Um, you can rewrite this in terms of y. You could solve for x, divide both sides by 3, and have x equals y over 3, which is the same as 1/3 y. So, x varies directly as y. So, so it can be rewritten like that. So, anyway, that's a little side note. I don't know where I was going with that. Point being, if y is always 3 times as big as x is always 1/3 the size of y. It kind of is reversible in that way. Yes. So when there's a situation like that where one variable is always a constant multiple of another, that's called a direct variation. And those things do exist in the real world, um, but we can also do it in a really abstract way, just calling them y and x, and it's a little boring. Agreed. So let's see how you'd actually set up one of those and figure out, basically what is k. So here's a little situation here. Y varies directly as x. So that's the clue, ding ding ding, that the relationship is going to look something like that, something kind of in that form. And that's the way it's said for whatever reason, varies directly as x. If it were me, I would say y varies directly with x, maybe. But for whatever reason, the way you say it is y varies directly as x. Maybe it's kind of implied y varies directly as x changes, or something like that. Okay, so y varies directly as x. We know that these two variables, y and x, um, will vary directly. That their relationship is a direct variation. And y equals 6 when x equals 3. So let me just graph this first. I'm assuming that's why I put this coordinate plane here. This was a while ago when I made this lesson, got it ready to go. So let's just graph it. It's always good to visualize stuff. Okay, so when x is 3, it tells us 1, 2, 3. Y is 6. 1, 2, 3, 4, 5, 6. So I'm just going to make a little mark there. So, 6, 3. Okay, all direct variations go through the origin. Oops, let me just actually draw a real. All direct variations go through the origin because no matter what k is, say when x is 0, 0 times whatever k happens to be in the situation will equal 0. 0 times anything is 0. So when x is 0, y will be 0. Therefore, a direct variation will go through the origin. Yeah. So here's what our line would look like. And you can just look at this. The constant of variation will actually correspond to the slope. If this, I don't know, this might blow your mind. Say like I were to write this as y, oops. Say like I were to write this so that you could actually see it. Y equals k x plus 0. What does that look like? Y equals mx plus b, right? So this is your slope, yeah, and it's the y-intercept is 0 because it goes to the origin. Anyway, so the if you were to graph a direct variation, the constant of variation is the slope, and so you can see here there's a slope of 2, right? For every positive change of 1 in the x-axis, you go up 2, so rise over run, the change in 2 over 1, so that's the line with the slope of 2. So we would know that if we were to write this equation, it's y equals 2 times x, right? You can also do it like this. Write it like this. So y equals 6 when x is 3. So we know we're going to have an equation that looks something like this. Y equals some constant times x. So we could just write it. All right, write what we know. Y equals kx. That's all we know so far. Okay, what else do we know? Okay, this is what y varies directly as x tells us that y equals kx. We know it's going to follow this form. Okay, y equals 6 when x is 3. So y 6 equals k times 3. Okay, that's what we know now. Alright, so we just solve for k. Divided by 3. Divided by 3. So it's being multiplied by 3, so we divide by 3 to get it by itself. 6 divided by 3 is 2, so k equals 2. So now we can go back and say, oh, hey, we know what k is. So y equals 2 times x. That would be the equation for this direct variation, which we know from graphing. We could take this information, put a point on. We know that a direct variation will go through the origin, and then we could just look at what's the slope. That's one method. Another method is to say we know the equation will take this form. We can plug in a y and an x, and then just solve for k. Either way. Alright, let's look at one more. So cupcakes varies directly as time in seconds. So we would put cupcakes up here, and we would put time in seconds over here. If it's uncertain, always guess putting the variable that has to do with time on the x-axis. Just a little hint there. Okay. So let's set up what we know so far. So cupcakes varies directly as time in seconds. So we know that c, cupcakes, equals some constant times seconds. Okay, now when 3 seconds have passed, I've eaten 12 cupcakes. So now we can rewrite this as 12 equals some number times 3 seconds. When 3 seconds have passed, I've eaten 12 cupcakes. So how many cupcakes will I have eaten after 10 seconds have passed? So let's solve this. Let's write up the equation first. Let's solve for k. Divide by 3. Divide by 3. 12 divided by 3 is 4. So cupcakes equals 4 times seconds. So if we were to graph this, our slope would be 4. No, that's 3. Let's see. Yeah, it's something like that. Let's see. 1, 2, 3, 4. 1, 2, 3. Yeah, something like that. That's a lot of cupcakes. That's eating a lot. That's probably too much. Okay, so cupcakes equals 4 times seconds. So cupcakes here is a constant multiple of seconds. So however many seconds have passed, I've eaten 4 times that many cupcakes. So how many cupcakes will I have eaten after 10 seconds have passed? So I'd plug in 10 here. 4 times 10 is 40. So I will have eaten 40 cupcakes after 10 seconds have passed. That's totally unrealistic and kind of disgusting, actually. Just a silly example. So that's direct variation. So first look for the keyword. It varies directly as. So you know it's going to take this form. And then you can either plug in a pair of values, or you can graph that pair of values and connect it to the origin and find out what the slope is. And then the slope is your constant of variation. Yeah? Alright, enjoy.